simplify the following expressions. So we have some trigonometric expressions, and we want to simplify them. And for that, we're going to have to use some trigonometric identities. Okay, and the final one is an exponential one. Okay, so let's go to it. Okay, so start with one. F of x is the sine of the arc cosine of x. Okay, so how do we simplify this? Okay, the idea here is, let's call this thing z. So now this is the sine of z. And the way to simplify this is to write the sine as in terms of the cosine. So let's say it's the sine of z. We want it to be written as a function. All right, let me write it. It's a function, let's call it g of the cosine of u. Okay, where u is a function of, in this case, z. Okay, I'm gonna use a different letter. Function h. Okay. So this may sound abstract, but what I mean by this is, okay, the way to simplify the arc cosine is to have something like that's the cosine of the arc cosine. Okay, because then we will have the argument. Okay, and so we want something cosine here. So the sine, how do you write the sine as the cosine? Well, you know, the easiest way to go with this is you have the basic trigonometric identity. That's the sine squared of z plus the cosine squared of z is 1, right? So then the sine squared is 1 minus the cosine squared. And so the sine of z is the square root of 1 minus the cosine squared of z. Okay? So this is a very basic substitution that you should be very familiar with. Okay? When, if not now, when whenever we're doing integrals later, it's gonna be very, very useful. Okay? So now we can use this and write this. This is the square root of 1 minus the cosine squared of z. Okay? But the cosine, let me erase this. The cosine square, so now write z is the arc cosine. This is the cosine of the arc cosine of x, and this is squared. Okay, so this is what it means, the cosine squared. So what's the cosine of the arc cosine of x? These two guys are inverse functions, so this is just x squared. Okay, and so we have 1 minus x squared. Okay, and yet that looks much simpler than this, right? So this is the thing we're aiming for. Okay. Now let's go for 2. F of x is the sine of 2 times the arc sine of x. Okay, so now what we want, so if you write again, this we call it z, and so this is, we have the sine of 2z. And again, because we have the arc sine, we want to write this as a combination of the sine of z, okay, not the sine of 2z, but we have a very simple expression for the sine of 2z, which is 2 sine of z cosine of z. And the cosine, as we have seen, is just the square root of 1 minus the sine squared of z. Okay? And so now here the sine of z is just the sine of the arc sine of x, which is x. And this is just like before, the sine squared of z is just x squared, so this is 2x and the square root of 1 minus x squared. Okay, this is what this thing is. Now for 3, f of x is the tangent of the arc cosine of x. Again, I'm going to call this z to make our lives easier. So this is the tangent of z. Okay, and so let's see, we want something again written in terms of the cosine, so let's deal. The tangent is just the sine of z divided by the cosine. Okay, so in the denominator we already have a cosine. In the numerator we have again 1 minus the cosine square of z, as we have been doing over and over. And so this is just 1 minus x squared, and this is just x, okay? The cosine of the arc cosine of x. Okay? Just like before. Now for f of x is the sine of 2 times the arc tangent of x. And I'm going to call this z. And so this is the sine of 2z. Okay, so now this is trickier because we have to write the tangent. Okay, I want something like at some point the sine of 2z is a function g of the tangent of z, such that I can substitute the tangent of the arc tangent, you know, and substitute like x, because you know the tangent of z is x, just in case this is not clear. Okay, so this is function g of x. So this is what I want, but this is not easy as before, or you know, not as easy as before with the sine and the tangent. Okay, so let's see how. Well, first of all, I have to change this. This is 2 times the sine of z cosine of z, and well, there are many ways to approach this, but I'm going to, let's see, this is the tangent is the sine over the cosine, so let me divide by the cosine here and multiply by the cosine, and then I have another cosine here. This is cosine squared, so this guy is tangent of z, so I have one tangent of z, but then now I have a cosine squared of z. So let me see what I do with that. So how can I relate the cosine squared of z with z? Sorry, with the tangent of z. Okay, so if we have the tangent of z is the sine of z divided by the cosine of z. Okay. Now if we squared everything, now we have the cosine here, right? So let's see. We could let me guess. If we divide by, you know, I want to get rid of this sine squared, but again, yeah, so it's easy enough. So we have the sine squared is just 1 minus the cosine squared of z, okay, and this is over the cosine squared of z. So what we have is 1 over the cosine squared of z minus 1, and so we can solve. So this is 1 plus the tangent squared of z is 1 over the cosine squared of z, and this expression you will eventually learn by heart because this is the derivative of the tangent. Okay, so the derivative of the tangent is 1 plus the tangent squared, or 1 over the cosine squared. Okay, and so what I want to do is write this in terms of the cosine, so I'm just solving for the cosine, and I have this. Okay, so I plug it in here. So this is 2 times the tangent of z divided by 1 plus the tangent squared of z. And we had said that the tangent of z is x, so this is 2 times x and then 1 plus x squared. Okay, now 5. F of x is the cosine of 2 times the arctangent of x. Okay, again, this is z, and So there are many ways to do it, but I'm thinking about it now. So this is, if you have this function, let's call it g now, the sine of 2 arc tangent of x, okay? And we have just said this is 2x over 1 plus x squared. So we know that f of x squared plus g of x squared, the sine plus the cosine squared, this is just 1. Okay? And so now what we want to solve is for f of x, this is 1 minus g of x squared, and this is the square root. Okay, if you solve for this. And so this is the square root of 1 minus, and then this is, let's see, this is 4x squared, and then 1 plus x squared. Okay? So you plug everything in the same fraction. So we have 1 plus x squared minus 4x squared. So, well, the denominator, you can get rid of the root, so this is 1, I am expanding the binomial, 1 plus x to the 4th plus 2x squared minus 4x squared, and then divided by 1 plus x squared. And as you can see here, what I'm getting rid of is this, and then I have a 2 here. And then it's x fourth minus 2x squared plus 1, which is just 1 minus x squared, but then it's the square root, and then 1 plus the square root. And so this is 1 minus the x squared and 1 plus x squared. Okay. There are other ways to do this. Okay, if you for instance, because this is kind of tricky because of the signs, but I just improvised this. Sorry. So in this case, let's do this again. Start from the beginning. Okay, different way to get to this. So I have the cosine of 2 z. We know the cosine of the double angle is cosine squared of z minus sine squared of z. And then, so this is cosine squared of z. Let's see. This is 1 over 1 plus the tangent squared of z. We have just seen this. And then minus, and then sine squared is 1 minus the cosine squared. So we have 2 times this, 1 plus the tangent squared of z minus 1. And so this is 2 minus 1 minus the tangent squared of z over 1 plus the tangent squared of z. So this is just 1 minus the tangent squared of z, and then 1 plus the tangent squared of z, and we know that the tangent of z is x, so the tangent squared is just x squared. So it's 1 minus x squared, 1 plus x squared, okay? Just like before. Okay, and without having to worry about the signs of the root and anything, okay? And then finally, and this is, I guess, the easiest one, f of x is the exponential of 4 to the logarithm of x. Okay, so we know for the properties of the logarithm that the 4 times the logarithm of x is just the logarithm of x to the 4th. So this is e to the log of x 4th, and this is just the exponential of the logarithm. So these two guys are inverse functions, so they kind of cancel each other, and we are left with x to the 4th. Okay, and actually, so that this is the standard way to write powers of x. Okay, so if we have x to the a, there's the standard way to deal with it is, or to define it in mathematical rigorous terms, is to write it like that. Okay, and then if you, for many proofs, you will need this. Okay, and that's it.